Good morning, students. Today class we are going to discussing about the new topic is time averages of random process. In this time averages, we are completely doing that the entire random process with respect to time parameter. In this case, the first function is time average function. Time average function. How to define the time average function? We need to consider the random process x of t. It is defined for all values of time. It is defined for all values of time. How to defining the random process? The random process we are defining with a sample function. Okay, sample function. The sample function of a random process is defined for all values of t at a fixed sample space. At fixed sample space, the time average we are defining that the average value of x of t, the average value of x of t is called the time average of random process x of t. It is denoted with x of t whole bar. X of t whole bar. Already you are seeing that the mean value also you are representing like this. But here the time average also you are representing the same notation. That one is x of t bar. X of t bar is equal to limit the t tends to infinite. Here the t, we are using a capital T. Capital T. Limit capital T tends to infinite 1 by the interval. What are the interval you have to consider in limits? Those interval you can writing here. That one is here I am consider the integration limits are the minus t to plus t. That's why I can making that the higher limit minus lower limit combination. But is the lower limit is having already the negative sign. That's why the t minus the minus t, the value is a 2t. That value I am writing in a denominator, and then I have to representing the integration of minus t to plus t x of t into dt. Here you can making the integration with respect to time parameter. Only the difference is we can making the limitation. The t tends to infinite is 1 by 2t integral. This is a function of time averages. The time average we are defining with the time parameter of the t tends to infinite is 1 by 2t integral minus t to t x of t into dt. This is a completely the time function, the time average function formula. And next one is a time autocorrelation function. Here you can observe that in any concept we must have go to its fundamental average value and cross correlation, autocorrelation function. These three parameters we are able to calculating those each and every concept. Here in time function also we are having to the second parameter, the time autocorrelation function. Here the time autocorrelation function we are able to defining. It is the average of x of t and x of t plus tau. Here the t plus tau. Tau is a time difference. The time difference. We can take that definition of time autocorrelation function. We can able to consider the random process x of t. For this random process x of t, we need to consider the time parameter is a normal t and time difference is a tau. You can take in these two parameters, we can applying the average concept on x of t, the product of x of t and x of t plus tau, we are calling the time autocorrelation function. The time autocorrelation function, we are given the notation is, in general we are writing the autocorrelation function is a rxs of tau. But we are using the time parameter, and how to using this time parameter we can crossing this r like a straight line. That is a notation for that autocorrelation function. Here is the average of x of t and x of t plus tau. The formula is limit, same thing, is a t tends to infinite and 1 by 2t is the interval of values, and integral minus t to t x of t into x of t plus tau into dt. This is the formula in that. Is x of t is a normal random process, x of t plus tau it is a time shifting random process. Both are having that integration with respect to dt. Coming to the next one. The next one is a time cross correlation function. Time cross correlation function. In time cross correlation function, we are able to define, you can consider two random processes. One is x of t and another one is y of t. Y of t. These two are we are able to defining it's a time difference is tau. Time difference is tau. And now to take in the time difference is tau, we can defining the time cross correlation function. It is the average of the product x of t and y of t plus tau. X of t and y of t plus tau. The notation of this time cross correlation function is we are writing r xy of tau for a normal, but we are using the time parameter, you can cross it r. This is the notation for the time cross correlation function. The time cross correlation function is rxy of tau is equal to a into x of t into y of t plus tau. The formula is limit t tends to infinite 1 by t is a complete interval, and integral minus t to t x of t into y of t plus tau into dt. And also can make in the difference is an integration with respect to time parameter. Now here you can see some limitations of the time averages. Those are the first one is the expected values of time averages. The expected values of time averages gives the ensemble averages. Ensemble averages. Here you can apply the expectation on your time averages. These are equivalent to the ensemble averages. Ensemble averages means it's a normal averages values like expectation value and cross correlation and autocorrelation. Here you can see that the formulas of those parameters is the expectation of the average of x of t. The time average function is a expectation of x of t bar is equal to x of t bar. The time function, what are the time function you have to consider? That function average value is equal to, when our top line expectation, it is a normal expectation value of random process. And the second thing is the expectation of autocorrelation function. Autocorrelation function time average and time autocorrelation function expectation value is equivalent to the normal autocorrelation function. When out applying the expectation value on time autocorrelation function. Coming to the third one, we can consider the expectation on the time average or a time cross correlation function. Time cross correlation function, it is equivalent to the normal cross correlation function on how to consider the expectation. Similarly, coming to the next important point is if time averages are constant. If time averages are constant, then what are the parameters you need to consider under time averages? Those also be a constant values. Like is x of t bar, it is a constant, and rx of tau, the time function is also be constant, and rxy of the time function is constant. What are the parameters we have to discuss in that? Those all are belongs to constant values. Now we can represent those constant value is the time average x of t is equivalent to normal expectation value of x of t, and rxs of tau for a time function, it is equivalent to the normal autocorrelation function. Similarly, you can consider the cross correlation time function is equivalent to the normal cross correlation function. Is a completely information about the time averages. We can see here the only the difference is we are taking the same formulas, but you can making the integration with respect to dt, and we are additionally joining the limit value. The limit is t tends to infinite 1 by 2t. The 2t is giving the interval values of integration. These are the formulas we are having under time averages. Coming to the next topic is a ergodic process. Ergodic process. Here the ergodic process we are easily defining that. You know the time averages, we can give in the relation between the time averaging values and ensemble values. Based on their relation, we can able to defining the ergodic process. Ergodic process or ergodic random process. The random process that satisfies the ergodic theorem statement. Ergodic theorem statement is called ergodic process. What is the definition? The random process that satisfies the ergodic theorem statement is called ergodic process. What is the ergodic statement? The ergodic statement is the time averaging functions is equal to the ensemble averages. The time averages is equal to the ensemble averages is called the ergodic statement. And I am writing here time averages is equal to ensemble. Ensemble means the normal averages. Normal averages. It is a ergodic theorem statement. Coming to the first one. In that first one is joint ergodic process. Joint ergodic process. Already we know that joint means it is having the two random processes like x of t and y of t. Those are two random processes x of t and y of t with the sample functions small x of t and y of t. Here the difference is we can consider the random process a capital X of t and y of t, and its sample functions you need to consider the smaller values of x of t and y of t. The two functions are said to be jointly ergodic. The two functions are said to be jointly ergodic if they are individually ergodic. If they are individually ergodic, we can simply say that those are jointly ergodic. For that, and also the time cross correlation function is equivalent to the ensemble cross correlation function. Ensemble cross correlation function. What he is saying that here, if they are individually ergodic, and the time cross correlation function is equivalent to the ensemble cross correlation function. Here in bottom I am writing here the x of t, the function is representing time value, is a time function value, is a time function average value, and here the right side function is representing the expectation value of a random process. Similarly, you can do the y of t. Here the y of t for left side is a time function, the time average function, and right side it is representing the expectation value of random process y of t. And second point is, what is the second point? Individually ergodic. Individually ergodic, we are checking their self autocorrelation function. The self function is the RXS of tau. Here we are again the notation is the time function. It's a time autocorrelation function is equivalent to the normal autocorrelation function. And the autocorrelation function of y in time function or time autocorrelation function of a random process y of t is equivalent to its normal autocorrelation function of random process y of t. Coming to the last point is time cross correlation function is equivalent to its ensemble cross correlation function. It's a time cross correlation function is Rxy of tau is equal to its ensemble cross correlation is Rxy of tau. When the random processes, those are x of t and y of t, those are satisfying these three conditions. We can set that the given random process is ergodic or jointly ergodic process. If you can check it, the given process or a given random process is a jointly ergodic, it must satisfy these three conditions. Any condition it is not satisfying that, we can simply say that it is not a jointly ergodic process. I'm not asking that, we can do this checking of these three statements. Coming to the next one is the mean ergodic. Mean ergodic means the time function of mean value is equivalent to its expected value. Here, if its time average of sample function x of t is a random process is equivalent to the ensemble average value. We are writing like is x of t bar Here I am giving the variation of those time function and normal and simple average. Here I am writing a small x, here a capital X. But whatever you can take that. But you can remember the time function mean value is equivalent to its expected value. Its expected value we can calling is a mean ergodic process. When you said that the given random process is a mean ergodic, the mean ergodic or ergodic in mean, can call in another words ergodic in mean. Mean ergodic or ergodic in mean we are able to defining if its time function is equivalent to its ensemble average value, we can call it a mean ergodic. And next one is a autocorrelation. Autocorrelation ergodic process. Here autocorrelation ergodic process also having the same thing. The same thing is if it's a time autocorrelation function is equivalent to its ensemble autocorrelation function. Ensemble autocorrelation function we can call in autocorrelation ergodic process, otherwise ergodic process in autocorrelation. Ergodic process in autocorrelation. The notation of the time parameter is Rx of tau. Can take in the line. This can be representing the time function of autocorrelation is equivalent to the ensemble autocorrelation function. Coming to the last one is a cross correlation function or cross correlation ergodic process. In this cross correlation ergodic process, you need to consider two random processes x of t and y of t. X of t and y of t. If it's a time cross correlation function, time cross correlation function of x of t and y of t is equivalent to the ensemble cross correlation function. Ensemble cross correlation function, that is Rxy of tau. Rxy of tau for time function is equal to Rxy of tau. When is satisfying the given two random processes are satisfying this condition, you can set that it is a cross correlation ergodic process. The remaining thing we are discussing in next class.